in order to develop the first column of stiffness matrix, we have to give unit displacement along x direction only. So, that is delta x is equal to 1. Okay. So, we have to give unit displacement at joint B. Okay. So, initially its position is B, now move on to the position of B dash. The distance between these two positions is equal to delta x is equal to 1. So, other two displacements are arrested. Okay. So, now we have to measure the force in 3 coordinates direction. Okay. So, along coordinate direction 1, so that is represents axial force, then along coordinate direction 2, that represents shear force, then along coordinate direction 3, it represents moment. Okay. So, in this case the beam subjected to only axial force, axial displacement only. So, that means this axial displacement is induced because of axial force only. Okay. No shear force, and bending one can't produce any axial displacement. So, in this case only axial force only induced. Okay. So, therefore, the K11 is equal to force developed in the direction 1 due to unit displacement in the direction 1. So, force is the axial force. Okay. In this case, this is the axial force P by delta. So, which is equal to P divided by, so deflection produced by axial force of P. So, this is our beam. So, this is our beam. So, apply P force, which produces a displacement of PL by AE. So, displacement PL by AE. So, from that the K11 is equal to AE by L, or so deflection induced by the axial force is equal to delta is equal to PL by AE, we already know. So, in this case we applied unit displacement, therefore, delta is equal to 1 is equal to PL by AE. So, from that P is equal to AE by L. So, therefore, K11 is equal to AE by L. Then K21 is equal to force developed in the direction 2 due to unit displacement in the direction 1. So, this is 0. So, shear force is 0. In this case, the shear force is 0. Shear force is 0. Then K31 is equal to force developed in the direction 3 due to unit displacement in the direction 1. So, moment also 0. So, in order to develop the first column of stiffness matrix, we have to provide only a displacement, that is translation along x direction only, delta x is equal to 1. So, this is our beam. So, we provide delta x is equal to 1 along the axis of the beam. Okay. So, this axial displacement only produced when a beam is subjected to axial force only. So, other two forces, that is shear force and moment, it can't produce any axial displacement. Okay. So, therefore, these two are 0, only K11 is equal to AE by L. Then step 2, to develop the second column of stiffness matrix, give unit displacement in direction 2 only and measure the force developed and recovered in all the coordinate direction. So, now we are going to develop the second column of stiffness matrix. For this, we have to provide a shear displacement, that is a delta y equal to 1. So, now support moves in vertically upward. I assume the support moves in vertically upward direction, that is a sinking of support. Okay. So, sinking means downward, in this case this is in upward direction. Okay. So, give unit displacement at coordinate 2 only, then other two displacements delta x and theta z should be 0. Okay. So, now measure the forces in 3 coordinate direction. So, first coordinate direction is the axial force, second coordinate direction is the shear force in upward direction, then third coordinate direction is the moment in clockwise direction. Okay. Clockwise direction at B. So, now let us consider this is a fixed beam. So, our restraint structure is a fixed beam, both ends are fixed. Now, give the vertical displacement, that is delta y is equal to 1, delta y is equal to 1. So, what is the fixed end moment? The fixed end moment induced is equal to at joint B this is 6 EI delta by L square. Okay. So, if you are giving a delta displacement at joint B at support B means the induced moment is equal to 6 EI delta by L square. Then support A also 6 EI delta by L square, both are in clockwise direction. In our case delta is equal to 1, we have provided unit displacement. So, therefore, the moment induced is equal to 6 EI delta by L square. So, now measure what is the axial force at joint B, shear force at joint B and moment at the joint B. Okay. So, for this we have to apply equilibrium equations. So, first apply summation of moment about support A is equal to 0. So, which is equal to V B into L minus V B into L. So, which creates anti-clockwise moment minus V B into L. Then M A is 6 A delta by L square. Then M B again, this is clockwise moment 6 A delta by L square equal to 0. So, from that V B is equal to 12 E I by L cube. Then summation of H equal to 0. So, this shear displacement it can't produce any horizontal reaction at this support. Okay. So, H A is equal to H B is equal to 0. Since there is no horizontal force, no horizontal reaction will be developed, and also this shear displacement it can't produce any horizontal reaction. Okay. Then moment, joint B moment, we already know the joint B moment which is equal to 6 EI by L square. Now, write the element of stiffness matrix K12. So, K12 means force developed in the direction 1 due to unit displacement and the direction unit displacement in the direction 2. Okay. So, K12, so force developed in direction 1, it is a axial force. At joint B there is no axial force, HB is equal to 0. So, therefore, K12 is equal to 0. Then K22 is equal to force developed in the direction 2 due to unit displacement in the direction 2. So, force developed is the vertical reaction VB, vertical reaction, that is the shear force developed at joint B. So, VB is equal to 12 EI by L cube. So, VB is in upward direction. So, our coordinate 2 direction also in upward. So, therefore, both are in same direction, it is taken as positive 12 EI by L cube. Then third one is K32. K32 means force developed in the direction 3 due to unit displacement in the direction 2. Okay. So, third coordinate direction is the moment at joint B. Okay. So, moment, what is the moment induced? The moment induced is a clockwise moment 6 EI by L square. So, therefore, K32 is equal to 6 EI by L square. The next third step, to develop third column of stiffness matrix, give unit displacement. So, in this case rotation at the direction 3 only and measure the force developed in all the coordinate direction 1, 2 and 3. So, the third coordinate is the moment coordinate or rotation coordinate. So, that is why we provided unit rotation at joint B. Okay. So, for the fixed beam, so both the ends are generally fixed. So, at this joint we have to provide unit rotation. Okay. So, for unit rotation, so what is the moment induced? Moment induced is equal to at joint B, at the end B is equal to 4 EI theta by L, at joint A 2 EI theta by L, where theta is equal to 1. So, we provide only a unit displacement. So, therefore, MB is equal to 4 EI by L, MA is equal to 2 EI by L. So, now apply equilibrium equation, then measure. So, what is the value of HB, BB and MB? Okay. So, first summation of moment about A is equal to 0. So, while applying this equilibrium equation, VB is equal to 6 EI by L square. So, it is in upward direction. Then HB is equal to 0. So, there is no horizontal force in this structure, then HB is equal to 0, and also this rotation it can't produce any axial force at this joint. Okay. So, only axial displacement produces axial force. Okay. So, therefore, the K13, the third column of the stiffness matrix K13. So, K13 means force developed in the direction 1 due to unit displacement in the direction 3. So, what is the force developed? Force developed in the direction 1 is the HB force, which is equal to 0. Then K23 is the force developed in the direction 2 due to unit force in the direction, unit force or unit rotation in the direction 3. So, K12 it is the direction of Vb. Okay, so Vb is equal to 6EI by L square. The direction of Vb is in upward direction, then coordinate 2 also in upward direction. So, therefore, both are in same direction, which is positive 6EI by L square. Then K33 is the force developed in the direction 3 due to unit displacement and the direction 3. So, force developed in the direction 3 is equal to mb. So, both directions, the coordinate direction and induced moment mb direction both are same. So, which is equal to 4EI by L. The final stiffness matrix is equal to AE by L, the first column AE by L 0 0, then second column 0, 12EI by L cube, 6EI by L square, then 0, 6EI by L square, 4EI by L.